to the other screen. So if you see me looking over here, it's because I will be keeping an eye out if there are any questions in the chat. So if you have any questions along the way, please feel free to put them there. And looks like I am sharing. So first, I want to say thank you all for taking time out to come and listening to this. Dynamic SQL is one of those things that I found myself, I feel like I was writing in Dynamic SQL because I was just doing so much with it. And all my projects, that's all I was doing, Dynamic SQL. So a lot of what this came up with from experiences that I had while pulling those things together. And so for those of you who don't know me, let me introduce myself. I've been working with a data platform for over 25 years. I was 3 when I started. Please don't do any math from there. I've mainly worked with SQL Server and on transactional systems, but I've done enough with some of the other data platforms and analytical systems and databases, just enough so I can do some damage. I'm a co-leader for the data platform Women in Tech user group. We'd love to have you join us and support women in tech in the data platform. I'm also a co-founder of a group called Witspiration, and what we do is data mentoring for women in the data platform. Again, if you're interested, let me know. I'm a Redgate community ambassador, and I'm also a Microsoft MVP for the data platform, which means I like putting together these sort of presentations and talking tech and getting into the nitty-gritty of things. So this is not the important things. This is really the important thing. I sing in an alto section. It's one of my choir. I've been doing that for a long time. I do bluegrass jams. I have a guitar and a mandolin. I'm kind of been neglecting recently. I love musical theater. And my husband, some of you all may know, Andy Yoon, he and I like to take pictures of our dogs doing geeky things because, well, I mean, he's a techie dog. Anyway, you're really here to learn more about Dynamic SQL. So let's think about what it is. My thought is really, it's just a batch of SQL statements that are created ad hoc and executed. That's pretty simple. That's all you need to know. You've mastered it, right? Well, it's all in the details. So what we're going to talk about is we'll think about some use cases as when you want to use Dynamic SQL. You don't always need to use it, but there's some really interesting use cases. We're going to talk about security. We'll review syntax, and then we'll spend most of our time in the demos and wrap it up with a couple tips and tricks for you to come away with. So use cases. First are those catch-all queries. So that's that single query that tries to account for all options available. You'll recognize those usually by a where clause where you have a column that equals a parameter or that parameter is null. And this is like just 5 options, but usually you see those and you have at least 50 of those. And within those, it gets even more complicated. Dynamic SQL is your friend. End user customized queries. This is another real world example. I've worked at software companies where we may have a condition where clients want to see different things on the page. So you can see things like dealership A. We're going to be using an auto dealership demo today. So dealership A may want to see VIN, true cost, invoice price. But dealership B on that same page wants to see VIN, base model name, package name, and MSRP. These are very different things and could be coming from different tables. Dynamic SQL is what you can use to help kind of pull some of that stuff together. This is what, when I was doing all those projects writing in Dynamic SQL for a couple of years, this is kind of what I was doing. I was having to deal with the same query that I needed to run in the same structure against different databases, tables, and columns. So as you can imagine, the basics were there, but what everything needed to look like for those queries was very different. But the thing is, we can't use variables for those. So you can't say select from @database. What you have to do is you have to create your dynamic SQL statement to allow for a variable to then be able to create, say, which database and specify from there. And the other example that I'd like to bring up is one we don't really think about, but it's something I've been using constantly over the years, and this is delay parsing. So there are cases where you want, when SQL Server gets a query, this is in all cases, it parses the query first before it executes and make sure everything is valid. But there are some cases you kind of want to hold off on that. Let's say you're running an upgrade statement. You run your select statement, and then later in your upgrade, you're going to drop that column. But then when you need to run that select statement again, you need it delayed because that column's not there. So you're going to get an error. By delaying parsing, it gives us a little more time, and so we can move past the error or prevent it from even happening because it just doesn't need to run. I want to start off by talking about security and vulnerabilities because this is one of the biggest problems with dynamic SQL. And that's our friend SQL injection. And hey, there's little Bobby tables. We all love little Bobby tables. This is why this cartoon exists, because of SQL injection. And this is one of the biggest risks we have with dynamic SQL. If you're not very careful to sanitize parameters and do protection to make sure that no one can inject bad things into your SQL statements in your dynamic SQL, this is what's going to happen. So you really want to make sure that we write it carefully and deal with some of those little odds and ends there and making sure that we're able to move past it. Syntax. The good news is there's only a couple ways to do this. The first one is saying exec or execute, and inside your parameters is what your dynamic SQL statement is. A lot of my examples, I'll put it into a parameter or a variable, and you'll see why. The second way is using execute SP execute SQL, and then you pass your parameter in or your variable in. This is really flexible. You have parameters that you can pass in and you can pass out, and it's very flexible and it's pretty secure. It's you want to be using it this way. The third way, it's not documented, it's not officially supported, but what it does is it will take your statement and run it across all of your databases on your instance. There is an extension that Aaron Bertrand had written that kind of makes it a little more flexible, but the basic is there. You run it, goes across everything, unless your dynamic SQL has logic to say, hey, if it's a system database, don't run it, or anything logic within it. But it is definitely an option that's available. But remember, it's not documented or officially supported. And we're going to prefer SP execute SQL. So now let's jump directly to the demos. All right. So with that, let me hop over here. And I'm using Management Studio 21, so a sneak preview for the presentation that's coming up later. So I'm going to, as I mentioned, we're going to use an auto dealership demo. I'm going to remind myself to turn on execution plans. And I have a disclaimer here. And it's kind of, I guess you could call it a mea culpa. I use nvarchar max a lot. Normally we talk about you want to make sure you use the right data type and right size. A lot of my demos, I use nvarchar max. Part of this is because I've done so much with dynamic SQL. I don't know how big that dynamic SQL statement's going to be. And I have written some, yes, they've been horrible, and they've probably been about 12,000 lines of code once it finally comes together. And yes, that's actually an improvement based on what it was before I got the code. It's bad. But because of that varying thing, I tend to use nvarchar max a lot. If you know it's going to be smaller, use the smaller size. But if it is truly you're coming up with some really complicated statements, you may need to make sure that it is varchar max. It actually is the limit of what we can hold. So that is the largest size string that SP execute SQL can accept. So it works. Again, be careful. And as for me, a lot of times if there's an anti-pattern, as long as you can justify it, there's a justification. Sometimes we need those here. All right, so let's go into it. So we're going to start with execute versus SP execute SQL. Most of these times we're going to be executing the same thing. So I'm going to start with something very basic. I'm going to use the same variable, the same value, and I'm going to pass it through SP execute SQL and exec. And the quick thing is you can see that it's coming up with the exact same results. I did turn execution plans on, but it's static data, so we don't have one. So let's go get some execution plans. Run this here, and we can see everything returned. And if we look at the execution plans, I'll zoom in a little bit. They're the same. It's the same statement. It comes up with the same plan. If I looked at the properties, it's all the same because it's running the same thing. This isn't really where these two differ. It gets into other places. But let's start expanding things. Let's say I want to do a select from different table. So now I'm going to make my table name a variable. I already said earlier, you can't run this, don't even bother. But what you can do is if you had an exec statement, you could run something like this. But as I said, I like putting everything in a variable so I can print out the statement, make sure I know what's being run. So I'm going to run all of this together. And if I look at, we can see I've got 10 rows. And if we look at my execution plan, what we can do is we can now see what was actually run, our select top 10 from inventory and top 10 from inventory. And messages, I have that select statement, so I can see right here what was actually selected. Oops, wrong one. All right. So let's talk security, because this is where SQL injection comes in. So let's do a quick example. I'm going to say my variable name, inventory, semicolon, select Boston, we have a problem. I'm in the Boston area. Let's just use it, say we have a problem. And both things run, and we can see now that, hey, we ran a second statement. So SQL injection was successful. Now let's try to break it. So my first thought, this is what I normally would do, is I put a square bracket. Why? Because a square bracket, everything inside that square bracket is what my object name is, right? So I'm going to protect myself by using that. So now I can say select top 10 from putting the bracket around my variable. Everything's going to be treated just like one, right? No, it didn't. That did not work. So if we look at messages, we can see what actually put together. I parsed everything together, but because I used the bracket as part of my variable, the way that statement was created, it didn't recognize that I wanted everything in my variable to be treated as a single object name. So this is why SQL injection was allowed. How do we prevent that? Quote name. So same thing, and I tried other ways to break it, and quote name really worked well. So what happens when I run this? If we look here at the message, we can see that the inventory, while I still have the square bracket, what I have here, it understands that it's part of whatever I'm putting in that variable. And it understands that everything inside that variable is what I want to treat as my object name. And so it can escape the square bracket by putting a second one there, and it put everything in. And so the entire statement is now treated as a single object. And so that's why it fails, because it thinks this entire thing is my object name. Now you could technically have your object name look like that and then it would select, but the likelihood is that's going to be pretty rare, and it's a much safer way to protect from SQL injection. I'm apologizing to past me and past coworkers for not realizing this was the way to do it and not that first way, but quote name, if you take away nothing else, use quote names whenever you have to use objects as part of your variables for dynamic SQL. It's the one time I like them. All right, so let's move on and think about different relationships of our dynamic SQL to the batch that it's in. So the first thing is, what is our batch from that we're working in? What is our batch when I do exec? What is exec sp execute SQL? And for fun, xp command shell. So we can see the first three, our dynamic SQL, the two ways of dynamic SQL, and our main batch, we are all in the same SPID, 73. XP command shell is in a different SPID, it's 55. So when we treat things as a batch, our dynamic SQL, it's important to understand that dynamic SQL is part of our batch. Everything we're working in that statement, dynamic SQL is part of it. This becomes important when we do things like temp tables. So I'm creating this temp table here, and then I'm going to look at some dynamic SQL. So normally what I do is if I need to take something from dynamic SQL and put it into a table, I'll say insert into my temp table, execute SP execute SQL. The other way I can think to do this is add my insert statement for the table as part of that dynamic SQL statement. So let me, I've got the first thing I want to do, right, I wanted to show this as my estimated execution plan, because we can also start seeing a little bit of the difference that we're doing here. Part of it is insert into temp table, exec SP execute SQL. So insert into table, exec to store procedure. That's how that's perceived. The second time, we just have our exec SP execute SQL. This becomes important when we look at our actual plans, and it'll and we'll use this later for troubleshooting as well. So I'm executing both of these together. And we can see the first, it works both ways. So this first result is from using insert into test, exec SP execute SQL. And the second one is where I have that dynamic SQL as part of my statement. The insert is part of my dynamic SQL. It still works, which is pretty cool. And when we look at our execution plan, we can now see that this first one, insert into temp table, our dynamic SQL statement, but the second one is our actual statement. Insert into our temp table, select our test value. So for troubleshooting and seeing what our plan is, this second one is giving me a lot more information that if I have to troubleshoot and performance tune, this is the information I want. So it's really interesting to think about the dynamic SQL, especially using SP execute SQL, thinking of it as if it is a stored procedure. And there are a couple other ways that works too, and this is when we start parameterizing our dynamic SQL. The first one is I'm going to use exec, and I'm going to pass in my variable, and I'm going to select my information. And oh, we have a problem here. So we talked about our dynamic SQL is part of the same batch, but it can't see local variables. So it's not fully part of the same context as the rest of the session. It's a really weird dynamic, and there's some really interesting, I don't want to say repercussions, but the way it works is just enough different that you really want to be aware of it. So now I have an issue using exec because I can't just put a parameter in here. I have to do fun things like, oh, I have to do conversions of my variables, which means if I'm using dates, I got to escape those or make sure the format's right and make sure, oh, if I have a single quote in my text, I got to escape it, all sorts of fun. But if I'm using SP execute SQL, this is where we start treating it like a store procedure. It's almost a temporary store procedure because I have a way to define my parameter for my stored proc and then pass that value to the parameter. So if I run both of these at the same time, it works and I get the same results. But when we look at the execution plan is also the same. But here it's base model equals 58. I've just hard-coded the query that I'm sending to have compiled and sitting in my cache. The other one is already parameterized. Sometimes this could be good, sometimes this could be bad, depending on when you're using dynamic SQL. Some people use dynamic SQL for things like parameter sniffing. Maybe you don't want it parameterized in this case, but here we can also see what the difference in terms of what we're actually executing from the SQL Server side based on what query is being pulled together. Now we could, for multiple parameters we want to pass in, for exec just using exec, oh look, I get to convert both of them. Yay! SP execute SQL, look, I can just pass both of those in or create both of those as parameters and then pass my variables and have those run. And same thing with the execution plan, everything's hard-coded the first way, and now we have parameters the second way. So we have reusability the second way, which is one of the reasons why people like that. One thing I want to point out is the parameters you pass don't have to match the parameter names. For example, if I'm saying base ID inside my dynamic SQL statement, what I'm passing to it doesn't have to be called base ID. I just have to make sure it's the same order. For example, if I go to this next example and I switch package ID and have that go first and base model ID second and reversing the order, I don't get the results because it now thinks my base model ID is 4, not 58 as I intended. So you do need to make sure the order that you put the parameters in line up, but the names don't have to be the same. But the cool thing is we also have output parameters. So if I did exec, if with exec, it's a result set. So I have to throw it in either a temp table or a table variable. Oh, what do I do for examples? And then I have a whole table variable I have to deal with. I don't want to deal with a table variable for output, but thinking like a stored procedure, SP execute SQL allows me to have an output parameter where I put that in for the parameter that I'm using, and then I declare the variable that I want to have that value taken out in as my output variable. And so now I just have a single variable with my result set. So that works pretty well. So I do see questions. Will we get different results with set stats IO on? For dynamic SQL, if they're both the same, if it's the same query, I think it depends, but I have a couple other examples which I may be able to show stats IO on later. So we'll get to that there. So that's one question that I've seen in the chat. So if you have other questions, please put those in. So let's keep going. So let's talk about what happens if you change the database inside your dynamic SQL statement. I have another database here called Superheroes. So I'm going to run these in combination. So I'm in my auto dealership demo. I changed databases inside my dynamic SQL statement. I'm now in Superheroes database. Outside that dynamic SQL, I'm still in my auto dealership demo. This is where I talked about it's the same session ID, same SPID, but the context of what's being executed in that dynamic SQL is still within the bounds of that dynamic SQL. There are certain things that you can't do. You can't use Go inside your dynamic SQL. So be careful, you still have some limitations. All right, transactions though, this is where all of that still comes into play. What I'm going to do is I'm going to create a transaction. I like naming my transactions. It's easier to limit and see just what I want to see. I'm going to create some data, do a select so we can see that transaction. I'm going to see if I can see that transaction from within my dynamic SQL. It's a very simple test. And so I have my inventory, my data, my computer's running a little slow. So first here, this is our query of the active transactions from outside, but I can see those same transactions within my dynamic SQL statement. So the transaction outside, it's still on inside, it's still there. So the next one is, what if I do it reverse? I'm going to create a transaction inside my dynamic SQL, do a select, and then I'm going to see if I can see it outside my statement. Oh, wait, I get an error. Transaction count after execute indicates a mismatched number of begin and commit statements. This one's weird. It's a little esoteric, but it gets to a heart of things that goes back to you want to make sure you always close your transactions properly. Erland Sommerskog has a great blog post. He gets into nitty-gritties and really detailed information, but it also explains what's going on. It's called nested transactions. And this is very similar to things that you'll see with things like triggers. So let's take a look at our transaction counts. So what I'm doing first is I'm looking at my session, whoops, wrong one, our session, and I'm seeing what's outside the transaction and what our nested level is. So before I started the transaction, it's 0 and I'm not nested. The first thing I do here is inside I do the same count once I've opened my dynamic SQL statement. And we can see my inside nest level is 2. what we're talking about is we're nesting everything within our dynamic SQL. So we've already nested. One nest level is the SP execute SQL. The second nest level is the statement that we've run as part of our dynamic SQL statement. There is a rule that when you have a transaction, you have to be at the same nest level when the transaction is done, or when you're done. I think the nest level has to be 0 or at the same level you started at when you have an open transaction. Because these two are out of whack when we had that earlier statement, that's where we got this error. We need that nest level to be the same inside or outside. That's why you can't leave an open transaction and close it outside of your dynamic SQL statement. It all needs to be done inside the statement. It's one of those weird esoteric things, but if you're using transactions, especially inside your dynamic SQL statement, you need to make sure you handle them within your dynamic SQL statement. That's really what we wanted to get to. I have an example in here where it does show that you have the same problem with exec. Nest level is just 1 instead of 2. It's one of those weird little things that little quirks of how it works, but it's still one of those important ones to think about how everything's working and really understanding your dynamic SQL is its own little box within that session. All right, other questions? Yes, there's a question about whether these scripts will be available. They will all be available on my GitHub. I have a couple updates that I will be updating later. A quick example of the MS for each DB. This means I'm going to run this and it's going to run across every single database in my instance. You can do it by running a cursor, but just a quick example to show how it runs. One thing, and I've got, let's see, how many different result sets? Oh, I'm not showing results as 1, 2, 3, 4, 5, one for all my databases. The last database ID I have is 17. So it's run across all of them. It's a quick example. I don't use it much. I actually tend to use cursors because I'm doing something more complex. But if you want it for something quick and easy, it's an option available for you. Let's get into some interesting things. So delayed parsing. When I did upgrades at previous clients or previous companies, I did this all the time. Essentially what we had is we used the same scripts for insert or updates. And we never really knew what version our database was in previously, or we never started at that point. We just said run the script and it needs to work regardless of where I'm starting. So as you make changes, we would run into issues. For example, we need to create a new schema for dynamic SQL. Well, schema create has to be the first statement, and it can be the only statement in that batch. So I can't do a check statement. So if I ran this, I'm going to get errors. I have a table here. If I select from this, I drop a column. My next release, I actually drop that column. This statement before it is going to run when I rerun the script. And then I have the fun piece of, I didn't name my primary key constraint. How do I go find which those are, and how do I come up with a fix? Well, this is the script that's going to fix that. So here's where I can do things like if my schema doesn't exist, I can do that check and use SP execute SQL to then create that statement. Because when it parses, as we showed earlier, it's parsing exec SP execute SQL. It's not parsing what's inside that dynamic SQL statement. It's not going to do that till it actually runs it. So I can get past the error of it checking to see if the schema exists. And again, it's in its own little context, so it doesn't even recognize that if exec statement before as well, which is why we can have this work. For the statement, the column may or may not exist. If it doesn't exist, it's not going to try to parse the statement. We know it doesn't exist, or there's a likelihood. We don't even want it to parse it. Just run it if it exists. If you say if exists and just the statement, sometimes I get it to work, sometimes I don't. If I don't trust it, I'm going to do it a way I know I can trust. I need that repeatability. And then last one for the version, I can use my dynamic SQL statement to say, hey, here's what I want that primary key to look like. I can pull it out. Here's my rename statement. I could even execute it. This example, I just selected it. but I can pull everything together the way I want it, run it, we're done. I don't even need to think about it, but it's going to follow the pattern I need it to fit. So this is how we can use that delayed parsing and dynamic SQL to do things like upgrades, things that we have to do all the time. Error handling. Let's move on to that one because this is an important one because even with dynamic SQL, we still need to handle errors. So in my auto dealership demo, I'm going to start with something basic. I'm going to stay within my local instance, but I'm still going to use Open Rosette. Part of the reason for this is one of the situations that I ran into that inspired me to do this session. So I felt like I really need to include Open Rosette. So the first thing I'm going to do is I'm going to do a basic select for my superheroes database using Open Rosette. And because it exists, I'm getting my results. Now I'm going to do one to a server that doesn't exist, my server called Chihuahua, because we have a dog and he's a Chihuahua mix and it made sense at the time. And we can make jokes about how he's really unhappy we don't have a server named after him. The one bad thing about Open Rosette is that when something fails, it takes a bit. So it usually takes about 18 seconds. When I was testing last night, let's see if it's the same. It is the same. All right, so I've got an error. So now we can catch it nicely using try catch. So it's very simple. I'm running my execute SQL. It's the same statement I had before with then begin try, and now I can catch it nicely. Another, let's say 8 seconds, 10 seconds. And so then it'll catch it in here. Now, Open Rosette gets a little tricky because the way it tries to capture information, or you still have to wait for that statement to come back. And we have gotten our statement and it caught nicely. I'm going to jump this next demo for time, but what you can see is we can use that try catch because we can catch errors. We can run a cursor. I can run both statements and I can make my server dynamic. And I can go run, catch the information, and throw it into my temp table. As you notice, I like putting my temp table inside my dynamic SQL statement. There's a reason for this. And again, it goes along with why I wanted Open Rosette. The issue I had is I was catching I think it was a double network hop, and I couldn't catch the error properly. And it wasn't until I threw the dynamic SQL statement or the insert into the temp table as part of my dynamic SQL statement that I was able to figure out why that was. And it has to go with how are we parsing and what error are we actually capturing? There are some errors that try catch actually cannot handle. It's unable to actually catch those errors for various reasons. But I was able to get this one to work. I was super excited. I finally got this to work last night. So hopefully, crossing fingers, we'll get it to work today. So I'm going to create this really dummy fake store procedure. And I'm going to throw an error, and then I'm going to select one null for one column. And I'm going to execute it. And this is what should happen. I'm going to throw an error, message 51,000, don't catch me. Now I'm going to run this twice. I'm going to go back to my auto dealership demo, and we're going to use Open Rosette. I'm going to create my person table, which is temp table, which is 2 columns. And I'm going to, in the first case, I'm going to insert a temp table, executing dynamic SQL. The second one, I'm going to add my insert into the temp table as part of the dynamic SQL statement. Let's see if this works. Ready? It's not quite working the way I wanted to because I got it to work last night. But one of the issues that we're running into is that, actually, I think I may know why that is. Hang on just a second. Part of it is I never created this version of the person statement first. I love it when you solve problems in demos. My original version of the person table, I think I do need to run this demo after all. So my first version of this, let me explain what's going on here. So one, some of this has to do with a caching issue. I have 2 versions of the temp table, one with 3 columns and one with 2 columns. And what I'm going to try to do is I want to capture different errors based on what the store procedure works. So the first version of this person table, I have 3 3 columns. So now let's try to recreate this again. I'm going to go back. I'm still in auto dealership demo. I'm going to drop my person table, recreate it, and let's see if I can get it to work this way. I think it may be a recompile error. Nope. All right. So the problem that I'm trying to recreate is what I was getting when I was testing this last night is one way I was getting the store procedure error of the don't catch me. The other way I'm catching the error because it's recognizing that I can't figure out what my store procedure is going to be sending. Because this way it was when I do it with the table as part of the dynamic SQL, the error catching and the parsing is catching something different than when it's just executing the statement by itself. So that's what I was hoping to show you. I'm kind of bummed that it didn't work. I had it last night, but with that, it's one of those things that you do need to figure out what you're trying to catch for and why. And when the error isn't quite what you're expecting, trying to change what SQL Server needs to parse maybe your dynamic SQL statement, maybe what you're looking for instead. I'm always bummed when this one doesn't work. All right, so with that, let's keep moving. If you have any, I know I feel like I'm going a million miles a minute. If you have any questions, feel free to drop those in the chat. But the next one I want to talk about are those catch-all queries. And this is really one of the biggest reasons I use dynamic SQL. You're trying to do everything all at once. And this is, like I said, this is one where I do want to turn stats IO on. And actually, in order to really see some of that, let's go down to this. And I'm going to run these two while I'm talking. These two take a while, and I want to have those go through, and we'll see what happens when we come out from there. But what I want to do is I have these two store procedures. This first one is our catch-all kitchen sink stored proc. So we can see I'm selecting a few things, but I have a lot of things from my join. In my where clause, I have a lot of variables based on the where clause. I have between, coalesce, all sorts of things that can make things really complicated for SQL Server Engine. Not all the time, but some of the time. And as I said, this is a tame version of what I've seen. I've seen it where the variable is null and exists in another big, 20-line piece of code with other variables and parameters in there that use the same sort of logic. It's really complicated and really messy and a lot of work that SQL Server may not need to be doing. What I did is I turned it into a store procedure that uses dynamic SQL. One of the big things that I do whenever I have to do that, or dynamic SQL anywhere in my store procedure, I add a debug parameter. And I set it to 0 because one, my application developers don't need to know it's there. I never want them to call it. So I'll add it if it already exists and they don't have to change their code. We don't use it, just we normally don't want it to run. But I want it here for fixing problems. The first thing I do is I create my parameter list because I'm going to use dynamic SQL, SP execute SQL. I want to pass my parameters in. Then I'm going to create my statement. One thing that I do is in my statement, I'm putting comments in to say what my store procedure name is. This is important. We'll come back to why later. Then I will do this is a common construct you'll see where 1 equals 1. This way, it's if you have everything that's dynamic, all your where clause being dynamic, you need something to kind of anchor your where clause. And trying to figure out, wait, is this the first thing that I need to add to my where clause, or is it the second? Do I need to start with and or not? 1 equals 1 makes it easy, and then everything else is and it works. Some people don't like it. It could cause weird things to happen. Sometimes it depends. Play with your queries. If you end up using this, figure out what works best for you. There are different ways you can construct your where clause and how you create the dynamic SQL depending on how complex your statements are. Lots of different options. This is what I'm going through for this one. But here I can do things such as if this is null or an empty string, I don't even need to add it to my where clause. if I'm doing price mins, and if both of them are min or max, do I really need to do a check of my price between 1 and 99999? Do I need to do that? That feels like extra work for me. So I'm only going to do if one of these values is valid. Same thing for dates. Oh, if I have to do dates and convert those, oh, what a pain. So now I can only do it if it's meeting the requirements that I want. The reason I use the debug is so I can print out my statements at the end. And then the last thing I do is execute my statement. You can have your debug value be used to say, actually, don't run it if I'm debugging, and then you just get your statement back, or you can have it both ways like I'm doing here. So now my two statements have run. So I ran this against everything. I took the defaults from the first, and I have the same defaults set up in my dynamic SQL. But this is where we can start seeing differences in the way things are done. Someone had asked about stats.io on earlier, and we have it here. And we can see there's some differences. For some reason, these are pretty similar because I think I managed to have these be exactly the same. But depending on how different your statements are and what you're doing, your IO can be very different because of what you're putting together. Logical reads, we'll come back to look at some of those differences. I'm just paying attention to a couple of these here first. So 30826 and 14111. But the second one is what I want to point out because I use that debug parameter. I can see what I actually executed. And we can see that I didn't do anything here. But we are seeing some differences because it's a very different query. I'm not doing any of the searches or anything for my where clause. I don't have anything. But we can see 31024, 14322. So I'm reading a lot more of the history than I was before. Or wait, that was 14. Oh, not too much. But we are seeing that the stats are a little different and in some ways a little higher. Maybe it is because I'm not doing the where clause. But this is one thing we can start doing to examine it. We also notice difference in execution plan. I'm always amazed by this, but the cost for some reason of the original one is showing as significantly a smaller cost. But hey, I'm seeing things like warnings here. Let's see if I can figure out what that says. Oh, it's TempDB spill. That's always fun. We like TempDB spills. So we can see that it's doing those sort of things, but we also see a very different plan shape here. And oh, hey, I don't have any TempDB spills, even though it thinks it's more expensive. Again, cost is a relative when we're looking at things, but we can also see there is a definite difference between the two plans. And if we wanted to do something a little shorter, we can do something of, just for the color black. We can also see if there's a similar difference. I'm not quite sure the plans for the older version are quote cheaper, but we do see things like we are getting spills to TempDB, and we are seeing definite plan differences between them when we start getting down to things where I don't have that TempDB spill in the second query. This is a very simplistic version of it, but you can kind of see where that difference is coming into play. Now, here's the thing with query tuning, as we're especially trying to figure things out where things are, how to fix the problem. It's hard with dynamic SQL, even in a store procedure, because that dynamic SQL while part of the same session, part of the same proc, we don't see it when we start looking at query plans and in Query Store. And I like Query Store for a number of reasons, but one of the things is we don't see it connected to the store procedure. I'm showing two different plans for my regular object, the search all inventory, but I don't see it for the dynamic one. And I executed something in my dynamic SQL statement in my store procedure, but we can see the statement here that select search all sold inventory dynamic. This is why I put the comment as part of my SQL text, because that's how we're going to have to find the dynamic SQL. We don't see anything about it. We can see it. We can see the query that comes out, but they're not connected. We have no way to know that these two plans were generated from the same store procedure. This is one of those little caveats with dynamic SQL that what you have to pay attention to. If I were to run a trace, you would be able to follow everything along in this bids, and you can see everything executed in the trace, and you can see everything that way. It just doesn't save that way in the query plan. So depending on how you're troubleshooting, you need to be aware of it. This is why I always put this comment in here so I can identify it back with the store procedure that that dynamic SQL was generated from. One of those things to think about when you're how you're setting this up for troubleshooting longer term. So looking for quick questions. I'm doing a quick break here. Let's see people looking at the temp table statement. I'm going to come back and look at that. So I have to drop it first as a separate command, recreate the temp table. Yeah, I'll have to play with that a little more. I'm going to get it one day. So thank you for that suggestion. There's another question. Most dynamic SQL can be redone into regular SQL. What are a couple of operations that require using dynamic SQL only and cannot be rewritten to regular non-dynamic SQL? I don't know if it's necessarily the statement itself. I think it's if the reusability of that statement. And a lot of the statements are there, but we're trying to, and a lot of times what we're trying to do is we're trying to help the optimizer. We have statements that get really complicated for the optimizer to work with. We have a lot of left joins that we need, a lot of things that if we didn't have to do, let's say, where clauses against, we wouldn't even need to include that table. So by including that, we're making SQL Server do a lot more logic. And a lot of times when I'll use dynamic SQL for that is because I'm trying to performance tune by saying only use what I need to use based on the values that are being passed to my store procedure. I don't think it's a matter of operations that require dynamic SQL. I think it's where the query is being executed, how it's being reused, who needs to reuse it, and any sort of performance tuning that we can get by creating our dynamic SQL on the fly. There are a couple of distinctions, but those are really my use cases for dynamic SQL. It's not reverting the other way, but it's really thinking about what problems were we trying to solve that reuse of the big monolithic store procedure or monolithic statement would be better if we were able to break it out and kind of pick and choose what we needed to create our statement. Hopefully, Vlad, that answers your question. So there's a question, one of the comments is understanding the difference between @debug equals 1. So the difference, so @debug 1 is really just a technique that I use to say, I want to see what statements are being generated through my dynamic SQL statement. So I can print them out when the store procedure is running. So I can make sure that whatever SQL statement I'm generating works. It is the statement that I'm looking for. So it's really just a technique to help me and find out what statement I'm about to execute. I've used it before a lot of times for like logging. So I can, if I need to say, hey, I'm running a whole bunch of things, I need to log what statements I'm actually running. But a debug statement I can also use for troubleshooting or having a coworker troubleshoot my store procedure by turning debug on. It's really just building in a way to help me figure out what I'm actually putting together with a dynamic SQL statement. Because in the end, that's what we're trying to do. We're trying to figure out what statement we're supposed to run. Hopefully that answers that question. Trying to see, I think that is there's a statement saying that they used support a database instance behind low code, no code front end that had ad hoc querying capability. It could be using dynamic SQL. It depends on what data layer is and how it puts it together. So it could, but it could depend. I've seen different ways of those being put together. Sometimes you have front end logic that creates the statement and runs it, but it's not actually dynamic SQL, or it's dynamic SQL and the data layer is putting it together, or the application's putting it together. That would depend on your application.
Hey, Deborah, you've got about 7 minutes left.
All right, so I've got one really cool thing that I want to show you, and that has to do with SQL Server 2025. So there's this new option, optimized SP execute SQL. We said we want to use it. This is why. Let's see if I can get a quick demo going. I have a public preview of 2025 on another instance. So what we have is we have 3 stored procedures all doing the same thing. I've made sure that optimized locking is turned off. If I ran each of these individually, what would happen is, because if it's been run, each of those stored procedures would use the same cache. But I'm going to clear out my procedure cache quickly. I'm going to jump over to, I have a command prompt, and I have a workload. If I can type quickly, command batch, which is going to quickly run those 3 statements that we saw. And of course, I have that statement wrong in my demo scripts. Okay, demo scripts 08. Whoops. 08. Here it is. I'm going to run those dynamic procs quickly. And if we run, we've got a worker thread. We can see that it ran. And if we look at our cache, we can see that 3 different compile plans for the same store procedure because of that dynamic SQL statement that was created. And it's a parameterized. It's the same one that you just saw, same store procedure. Now I'm going to turn that optimize SP execute SQL on. I'm going to clear out the procedure cache. I'm going to go back to my command now that I have what it is. I'm going to run it. All it's doing is running the three scripts at the exact same time. And if we run, it's able to figure out that someone else is also compiling this plan. Let me wait a few seconds, and then it's there. So we're getting a lot more plan reusability with SQL Server 2025. This is just the quick demo, and this is code that's available to all of you and all of us so we can sit and play with and really see what it is. But if we do a lot of dynamic SQL and we have a lot of people creating store procedures that use dynamic SQL with that same plan at the same time, this may help with plan bloat, and we may not see it as much. So keep an eye out for this. So that's the last thing I wanted to show you. With that, I want to go back quickly and a couple tips and tricks, and we'll see if I have any time left for questions. First, adding that @debug bit to your proc so you have a way to see what you're creating. Validate your parameters. Quote name your objects. Make sure that people can't do SQL injection through your dynamic SQL statements. Add error handling. The statement that we're getting that's being created, that's what you're going to performance tune. You're using dynamic SQL to usually create a better SQL statement. So you're going to look at what you're creating to make sure that that actually is what you're doing. So that's really the whole key and one of the most used reasons why we have dynamic SQL and why you'll see it in places to really create those really finely tuned statements based on parameters. I have a bunch of resources for you. These are all going to be uploaded to my website, to my GitHub, so they'll be available for you. These are different resources. Tara Kaiser, why you want to use SP Execute SQL. Tim and Eitan talk about Aaron Bertrand's extension for MS4HDB. I have Erlin's blog. Kenneth Fisher also has a demystifying dynamic SQL session if you're interested in that. I have my blog post that inspired the session along with the Microsoft documentation. So with that, I can't believe I made it with like 2 minutes to spare. So thank you so much for being here. If you have any questions, let me know. I'm on Blue Sky more than Mastodon, but I'm in both places. I think there was another question. Dynamic SQL and execution sequence, can it be tracked as like T-SQL? So I think the question is saying, can you see the dynamic SQL in traces and in query store so you can performance tune them later? And the answer is yes. As I mentioned for query store, you can look for the query. If you have it as part of a store procedure, you may want to add some sort of comments that will allow you to attach it to the store procedure later, just because it's in a different context. So it's not associated with it directly through the code or through SQL Server mechanisms. But if you trace it, you can absolutely see what statements being created and being run. So you can absolutely use the same things that you use for other statements. It may be slightly different, but it's still there. I think that may have been the last question. Anything else that I can answer for people?
So, Deborah, is that the GitHub location? Will that have the scripts?
Yes, and I'm going to be uploading those shortly afterwards. I made some
Okay.
last minute changes, so I need to make sure those are there, but everything else should be there. And I'll try to make sure that's done by the end of today.
Thank you for a wonderful presentation.
Well, thank you all for taking time out and coming and listening to this. And if you have any questions afterwards, feel free to let me know. So thank you all so much.
Great job, Deb.
Thank you. Thanks for coming.
Well, see you in September.
Yes.
Certainly.